Hello, we are Team 19, comprised of
Evan,
Sandra,
Remy.
Nathan.
Pablo.
Okay, let's begin. First, we have the contents of proposal. The production volume for our 3D printer, which is what we chose. The estimated demand is somewhere around 300,000 units annually in 2023, most from the US. The industry is expected to grow somewhere roughly 20% compound annual growth rate. The primary and secondary customers are product designers who use 3D printers to develop product prototypes. And the secondary customers are medical professionals who create 3D parts for prosthetics, implants, and there's also the inclusion of hobbyists who create 3D printers for all sorts of different items. This is our modularization. So initially, it only came with one spool. We decided we were going to modulize the second spool because basically the 3D printer is fairly modularized already. So we decided this is what we were going to do. Moving on.
doing a deep dive in primary and secondary customers. The primary customers include engineers and product designers who rely on 3D printers for prototyping and custom component development. They require precision, flexibility with various filament materials, and reliability to create accurate parts. Additionally, medical professionals use 3D printed to produce custom prosthetics, medical devices, and anatomical models with a strong focus on precision and compatibility with medical-grade materials. As for secondary customers, are educational institutions for teaching and researching purposes, small and medium enterprises, for low-volume manufacturing, and R&D departments that experiment with new designs and materials.
Moving on to product analysis, we can go into the function analysis of the 3D printer. We have one main functive branch, which is to print a design. One assembly sequence involves starting with the base, adding the control boards and all the rails for movement, then adding in the end stops and motor assemblies, then adding in the extruder with subassembly with the stepper motor that moves the filament, adding in the hot end and cooling fan assembly, then putting in the LCD screen, power supply, frame, and filament spool. Assembly sequence 2 involves putting the power supply, control board, and LCD screen in first as they're closer to the bottom of the assembly, then moving on to the extruder assembly, then the rail assembly and the end stop assembly, assemble the motors onto the end stops or onto the rails, and then add the cooling fan onto the hot end. And lastly, put the filament spool and frame assembly around the 3D printer. Comparing the two assemblies, we found that sequence 2 was better due to the ease of transferring and handling, locating, and testing sub-assemblies.
We have calculated the cost of materials and manual assembly, assuming labor costs at 15 per hour. Key components such as frame, stepper motors, heating element, print bed, extruder, and control board make up the bulk of the cost. Pre-purchased items are motors, sensors. Those ones are integrated into the assembly, but the electronic components will not be redesigned, allowing us to focus on improving mechanical components. The total cost is a combination of material expenses and manual assembly time.
Moving on to the function component mapping matrix, we have mapped the parts as well to their functional components for the final assembly, with the temperature regulation precision control being the modular functions. Next, please. We have also put the quad chart characterization in place and found out that frames, stepper motors, extruder assembly, control board, end stops, and rails are functionally important but have high costs associated with them. Thus, they're the primary candidates to require the redesign. Next, please.
moving on to our product family design. The functions of our designs are very similar, but the designs between primary and secondary customers Differ in terms of temperature regulation and precision control. Our design is able to modularize very easily, having modules for the cooling fan and extruder assembly, which makes it much easier to assemble the different designs within the family. In order to decrease the number of nodes, we can use the modularity of the printer to our advantage by adding the extruder, cooling fans, and filament spools at the end of the assembly sequence. We are able to simplify our process, keeping a standard printer until the addition of the primary and secondary variations.
Thank you for listening to our presentation.